Hello, we are Group D and the members are Gonzalez Ana Abing, Helvicia Zunrun, Wong Waite, and Lo Huize. Today, we are going to show our teaching techniques on the topics 2.3 Introduction to Techniques of Differentiation. Firstly, we have derivative of a constant. If graph f is a straight horizontal of slope 0, the tangent to the graph of f is slope 0 for every x. So we can see here, this is a straight horizontal line that touches at y equal to c, where c is a constant number, and which means it can be any number. If we draw a straight tangent line here, or any value of x, we can see that it's a vertical straight line with a slope of 0. Hence, we can say that f prime x is equal to 0. Next, we can show it with formula, where in the end we will get c minus c over h, and the answer will be 0, hence proving that f prime x is equal to 0 for any constant. We proceed to the theorem so that we can understand it much better. Here we see that the derivative of a constant function is 0, that is, if c is any real number. We can see here the differentiation of c, any real number, is equal to 0. Here are some examples. We can see here where 1 is an element of real number, and if we differentiate it, we will get 0. It goes with 3, which is also an element of real number, and if we differentiate it, we will get 0. And here we can see pi. Pi has a value of 3.142, which is included in the element of real number, and the theorem also applies to it, which means the differentiation of pi is also equal to 0. And also negative 10, if we differentiate it, we will get 0. Okay, we proceed to the derivative of power function. 2.3.2 theorem, the power rule, where it says that if n is a positive integer, then the differentiation of x to the power of n is equal to nx minus nx to the power of n minus 1. So here's where we can see that here's the formula, and we expand this part until xn plus nx n minus 1 h plus h and yada 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 until h power of n minus x power of n over h. So here we do the subtract and division, where we subtract the equation in bracket with x minus n, so we eliminate this x power of n with this x power of n, and we divide the remaining with h, so we get this one. And then lastly, we substitute the value of h with 0, which means that any part that has h will be equal to 0, since any numbers times with h is equal to 0. Times with 0 is equal to 0. And then here we see that this is the only part that doesn't have h in it, and see here it has h here, and so does this, and so does this, and any element here will have h, and surely it will equal to 0, so we will get nx power of n minus 1 plus 0 and yada 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 until plus 0. So we will get nx n minus 1, hence proving that the differentiation of x to the power of n is equal to nx to the power of n minus 1. Here are some examples where x to the power of 3, if we differentiate it, we just need to bring this 3 to the front, and we will we will subtract it with 1, so we will get 3x squared. And it applies here too, where we bring the 4 to front and we minus it with 1, so we multiply this 4 with 2x. It also applies here, where this x actually has 1 in it, and but this one has 2 in it. So all we need to do is a simple multiplication, and we get 8x cubed. Although the proof that we show here is for n of a positive integer, the same rule can also be used for any power of x. For example, square root of x, if we differentiate it, we will get 1 over 2 square root of x. So we can also show it by changing square root of x in this form, where it is equal to x to the power of 1 over 2. Where we use the same rule, we bring this 1 over 2 to the front, and we subtract it with 1, which we will get 1 over 2x to the power of negative 1 over 2. This is equal to this one here, where 1 over 2 is 1 over 2x to the power of negative 1 over 2 is equal to this here, 1 over 2 square root x, where here, if we proceed, the x will go to 2 here, and as we see here, x to the power of 1 over 2 is equal to square root x. So it shows that the formula differentiation of x to the power of n can be used for any power of x. That's all. Thank you.
Hello, my name is Elucia Zangran with matrix number D202010937772. Today, in this slide, I will teach about a derivative of power function. This is a theorem of extended power rule with n in any real number. Differentiate of x power of n, bring this to n in the front of x, then the power e minus 1. Let's see to the example 1. Differentiate of x power of pi. Pi is a example of n that equal to irrational number. So differentiate of x power of pi, this pi we bring in the front of x, and then the power e minus 1. Example 2. Differentiate of 1 over x. 1 over x also we can write to x power of negative 1. Then differentiate this, we get a negative 1, and then x power of negative 2. Because negative 1 we minus 1, we get negative 2. We also can write to bring the x to denominator like this. Example 3. Differentiate of cube root of x. We also can write to x power of 1 over 3, and then differentiate this, bring the 1 over 3 to in front x, and then the power we minus 1. We minus 1, we get negative power of negative 2 over 3. Then the answer is 1 over 3 x power of negative 2 over 3. We also can write in terms of this. Simple exercise. Find dy dx. Question, exercise 1. Y equal to x power of negative 5. Negative 5. Dy dx, we get power of negative 5, bring in the front x, and then the power u minus 1, we get negative 6. Example 2. Differentiate y equal to x power of e. This example of exponent or irrational number. Differentiate this, or we get bring this power in the front x, and then minus 1. Theorem constant multiple rule. If f is differentiable at x and c is any real number, then cf is also differentiable at x, and this is a theorem of constant multiple rule. Means that the c is a constant, and then the fx is a function. Then differentiate this, we can bring this constant to front, to outside and then we differentiate the function. To more understand, let's see to the example. Differentiate of 4x power of 8. This 4 is a constant we can take to the outside and then differentiate this x power of 8 and then we get 4 times 8 x power of 8 dv minus 1. Then we get 70. 8 4 times 8 we get 32 and x power of 7. Example 2, differentiate of negative x power of 12. Differentiate this, we take the outside negative 1 and then differentiate this x power of 12. We get negative 12 x power of 11. Example 3, differentiate is pi over x. Pi over x, this pi is a constant. We can take the outside and then 1 over x also can write to x power of negative 1 and then differentiate this x power of negative 1, we get negative x power of negative 2 because with this power with minus 1 we get negative 2 and then we also can write to this form. Simple exercise, find dy dx. Exercise 1, y equal to 6x. So dy dx, we get 6. Because this x is have a power 1, and then the 1 we minus 1 times the 6, and then the power of 1 we minus 1 we get x power of 0. X power of 0 also we get 1. So the answer is 6 only. Then exercise 2, y equal to 6x. The set also inside the x and then dy dx we can separate first to more easier this set 6 because the theorem of set. Then dy dx, this function set x we differentiate we get 1 over 2 and then the x power of 1 over 2 minus 1 and the answer is set 6 over 2 times 1 over set x, we get set 6 over 2 set x.
Now we are going to derivative of sum and difference. Now we are going to prove that d dx of fx plus gx will equal to d dx of fx plus d dx of gx. So first step, we need to use limit h approach to 0, which we learned before of this. Okay, the formula, use this formula. Okay, f s plus h plus g s plus h, then minus fx plus gx, then we divide by h. This part is refer to this part fx plus h, while this part will refer to this part. Okay, then after of this first step, then we are going to next step, which is we are going to rearrange it, fx plus h minus fx, okay, plus g s plus h minus gh, then divide by h. Okay, so we categorize it already, then we can be separate it. Okay, we separate it, then we can get the limit h approach 0, then fx plus h minus fx divided by h plus limit h approach to 0 g x plus h minus gx divided by h. Okay, so we refer to this formula. We can get ddx of fx plus ddx of gx. So this equations is already we proved just now. It is some roots. It can be expressed as bracket f plus g bracket prime equal to f prime plus g prime. Next, this equation is difference roots. It can be expressed as bracket f minus g bracket prime equal to f prime minus g prime. For these difference rules, it can be proved in a similar way with some rules. Okay, by writing fx minus gs as fx plus negative 1 gx. So now we are looking for some example. Example 1. Okay, it is given the equations 5x power of 4 plus 2x power of negative 3. We need to find the ddx. So we just put in the equations into here ddx. Okay, then we need to separate it into two parts, which is ddx 5x power of 4 plus ddx 2x negative 3. Then okay, we undergo the differentiations. We get the answer 20x power of 3 minus 6x power of negative 4. Next, dy dx of x power of negative 3 minus 1 over x power of 9. Okay, so we need to put the equation into ddx. Okay, then after of this, we bring the x power of 9 become the numerator. Okay, then it will become x power of negative 9. Then we need to separate it into two parts. Okay, which is ddx bracket x power of negative 3 bracket minus ddx bracket s power of negative 9 brackets. Okay, then after we separate it, then we can be undergo the differentiations. So we get the answer negative 3x power of negative 4 plus 9x power of negative 10. So we can express it simply become negative 3 over x power of 4 plus 9 over x power of 10. Okay, exercise 1. It is given that the equations, which is 3x power of 6 plus 6x power of 3 minus 5x plus 9. Then we need to find the ddx. So to find out the ddx, we need to rewrite into ddx 3x power of 6 plus 4x power of 3 minus 5x plus 9. Then we separate it into 4 parts, which is ddx 3x power of 6, ddx 4x power of 3 minus ddx 5x plus ddx 9. Then we undergo the differentiations. Then we get the answer 18x power of 5 plus 12x power of 2 minus 5. For the next questions, we need to find out the value of y prime when x is equal to 2. So we are using the equations that we already found out. Okay, then substitute the value of x, which is 2. Okay, then we can get the answer 619.
Okay, now I'm going to teach about higher derivatives. F prime x, which known as the derivative of the function fx, and itself also can be defined as a function. Hence, it may have its own derivative as known as second derivative. A second derivative of a function fx can be denoted by f prime prime x. If the second derivative of the function still has differentiability, we can obtain third, fourth, fifth, or even higher derivative of the function. Okay, let y equal to fx. We undergo the first derivative and we will get y prime equal to dy dx. As written as above, a dy dx also can be defined as a function. If a dy dx still has differentiability, we can obtain higher derivative of the function. So we continue with the second derivative and we will get d2y dx squared. The third derivative, d3y dx cubed, and so on. The number of times the function fx undergo differentiation is called order of the derivative. The general n order of the derivative can be denoted by fn x equal to dny dxn. The value of a general n order derivative at a specific point x equal to x naught can be denoted by fn x naught equal to dny dxn with x equal to x naught. Okay, now look at some example. The first example shows that fx equal to 3x cubed minus 2x squared plus x plus 100. The first derivative we will get 9x squared minus 4x plus 1. The second derivative 18x minus 4. The third derivative we will get 18, which is just a constant. At the fourth derivative we will only get a 0 since the third derivative doesn't have any unknowns or differentiability to undergo a higher derivative. So we can conclude that when n is greater or equal to than 4, the higher derivative of the function will only give us a 0. For the second example, fx equal to 5x to the power 4 plus 3x cubed minus 8x squared plus 4x plus 9. The first derivative we will get 20x cubed plus 9x squared minus 16x plus 4. The second derivative 60x squared plus 18x minus 16. The third derivative 120x plus 18. And the fourth derivative we will only get a constant, which is 120. And starting the fifth derivative until the infinity n derivative, we will only get a 0 for the answer. Okay, let's do some simple exercise which find d2y over dx squared. The first question, y equal to 9x squared plus 8x minus 16. The first derivative we will get dy dx equal to 18x plus 8. The second derivative we will get 18 as a constant. For the second question, y equal to x to the power 4 plus 7x to the square plus 49. The first derivative we will get 4x cubed plus 14x. and the second derivative we will get 12x for the answer. And the third question, y equal to 18x to the power of 6 minus 31x to the power of 4 plus 24x cubed plus x. The first derivative we will get 108 x to the power of 5 minus 124x cubed plus 72x squared plus x. And lastly, the second derivative we will get 540x to the power of 4 minus 372x squared plus 144x. Okay, the next exercises is to find d3y dx3 with x equal to 3. For the first question, y equal to negative 3x to the power of negative 1 plus 5. The first derivative we will get 3x to the power of negative 2. Then we keep continue undergo the second derivative we will get negative 6x to the power of negative 3. And the third derivative we will get 18x to the power of 4, negative 4. And lastly, we have to substitute x equal to 3 to get a final answer, which we will get 2 over 9. And for the second question, y equal to 2x plus 3x cubed. Okay, the first we have to simplify the equation, and we will get 2x to the power of 1 over 2 plus 3x cubed. The first derivative we will get 2x to the power of negative 1 over 2 plus 9x squared. And the second derivative we will get negative 2x to the power of negative 3 over 2 plus 18x. And lastly, we will get 3 times 2x to the power of negative 5 over 2 plus 18 as our third derivative. And lastly, the final answer we have to substitute 3 into the third derivative, and we will get 18.0340, and we round off to get 18.03. Thank you.